Adding fractions. In order to add 2 over x plus 1 to 3 over x subtract 2, we need a common denominator. We look at the denominators that we have, x plus 1, x subtract 2. We multiply these to give a common denominator, x plus 1, x subtract 2. Take the first fraction, 2 over x plus 1. In order for this to have a denominator, x plus 1, multiplied by x subtract 2, we've multiplied the denominator by x subtract 2. This means we multiply the numerator by x subtract 2 in order to keep the original fraction equivalent to 2 over x plus 1. The second fraction we multiply by x add 1, top and bottom. So this gives our common denominator that we need, x subtract 2x plus 1. Now we have numerator 2 bracket x subtract 2 add 3 bracket x plus 1. Multiplying the numerator out, 2x subtract 4 plus 3x plus 3, all upon x plus 1, x subtract 2. Then we can tidy up and collect like terms on the numerator, 5x subtract 1 over x plus 1, x subtract 2. The fraction 5x subtract 1 all upon x plus 1, x subtract 2. Originally started off being 2 over x plus 1 plus 3 over x subtract 2. So the form on the left was a fraction, and the form on the right hand side is two fractions, so this is known as partial fractions. In the previous slide, we began with the partial fractions and added them up using common denominator to give the left hand side. So what we're going to be doing is taking something which is a fraction such as this and breaking it down into two or more partial fractions. It's just the reverse of the process of adding fractions. Reverse adding fractions is how we get partial fractions. Therefore, if we were given 5x subtract 1 all upon x plus 1, x subtract 2, and we wish to get two fractions, one with denominator x plus 1 and the other with the x subtract 2 denominator. So we're going to use x plus 1 and x subtract 2 as the denominators because these are the factors of the denominator. At the moment we don't know what the numerators are going to be, so we just set them up with a and b, which are unknown terms, and calculate what a and b are. Looking at the right hand side, what we would have done with this is get a common denominator. So we know already that the common denominator was x plus 1 x subtract 2. And we needed to multiply our a by the other denominator, a bracket x subtract 2, and our b by the corresponding opposite denominator, b bracket x plus 1. This is how to add up fractions. Therefore, we know that all of that on the right hand side is equal to 5x subtract 1, if we choose the correct values for a and b. So working backwards, we're trying to find out what a and b are. Here, both sides of my equation have the same denominator. So we can equate the numerators. 5x subtract 1 is equal to a bracket x subtract 2, add b bracket x plus 1. And now we have to find out what a and b are. Find a and b. Five x subtract 1 equals a bracket x subtract 2 plus b bracket x plus 1. The easiest way to find a and b is to choose a value for x which makes sum of the right hand side equal to 0. So we look at the bracket x subtract 2. Now if we make x equal to 2, this bracket ends up being 0. So x equals 2, substitute 2 wherever you see the x and run it through. 5 times 2 subtract 1 equals a bracket 2 subtract 2 plus b bracket 2 add 1. This bracket is 0. Left hand side is 10 subtract 1, 9. 0 there. And that's 3b. So 9 equals 3b. You should end up with an easy equation to solve. 3 equals b. That's b done. 5x subtract 1 equals a x subtract 2 plus b x add 1. Look for another easy value of x. So this time look at the other bracket, x plus 1, and choose if x is negative 1. That bracket will end up being 0. Run x equals negative 1 through the equation. 5 times negative 1 subtract 1, a negative 1 subtract 2 plus b multiplied by negative 1 add 1. 5 times negative 1 subtract 1 is negative 6. This is negative 3 times a. This part ends up being 0. So negative 6 equals negative 3a, and a equals 2. So we've just worked out that a equals 2 and b equals 3. So 5x subtract 1 all upon x plus 1 x subtract 2 is equal to a divided by x plus 1 plus b over x subtract 2. That's what we had in the beginning. Substitute a and b. 2 over x plus 1, 3 over x subtract 2. This is good, because this was our original. When we added these two fractions up on the first slide of this video, we started with the right hand side over here, the two separate fractions, and we got the left hand side. So it works both ways, using the method of partial fractions to break the 5x subtract 1 all upon x plus 1 x subtract 2 into the two individual fractions. Example 1. Express 5x plus 18 all upon x squared, add 3x, subtract 10. Express as partial fractions. Before we start, we have to factorise the denominator. So it's a quadratic, 2 brackets, x multiplied by x is x squared, and we need two numbers that multiply to give -10 and add to give 3. So that would be +5 and -2. Multiply to give -10 and add to give 3. So the factors are x plus 5, x subtract 2. Break it into its partial fractions. A unknown, x plus 5, and b over x subtract 2. It doesn't matter which you put first, if you put x plus 5 first or x subtract 2 first, because the end result is the same. So these two fractions equal our original 5x plus 18 all upon x squared plus 3x subtract 10. So the important thing to note is the numerator of the right hand side, 5x plus 18. Leave that there. Over on the left, a multiplied by the other denominator and b multiplied by the other denominator is equal to the numerator, 5x plus 18. Find a and b by choosing convenient values of x. Choose x equals 2, so that when we run 2 through, 2 minus 2, plus b, 2 plus 5, equals 5 times 2 plus 18. That means the first bracket is 0. And here we have 7b, 5 times 2 is 10, plus 18 is 28. So we have 7b equals 28 and b equals 4. That's b found. The equation was a, x minus 2, plus b, x add 5, equals 5x plus 18. This time, choose x equals -5. A times -5 subtract 2, the second bracket becomes 0. 5 times -5 plus 18. -7a equals -25 plus 18, -7. So a equals 1. Finishing off, we can write our fraction as 1 over x plus 5 plus 4 over x subtract 2 is equal to 5x plus 18 over x squared plus 3x subtract 10. And if you're not convinced you've got the right answer, just start with the stuff on the left hand side, multiply the fractions together, and you should end up with this answer. Example 2. express x subtract 11 over x squared subtract 12x plus 35 as partial fractions. First of all, factorise the denominator. 2 brackets. X multiplied by x. You need two numbers multiplying to 35 and adding to negative 12. That'll have to be negative 5 times negative 7 equals 35, and they add up to negative 12. Negative 5, negative 7. Set up your partial fraction. A over x subtract 5 plus b over x subtract 7. So a multiplied by x subtract 7 plus b multiplied by x subtract 5 equals the numerator, x subtract 11. Just copy that here. Choosing values for x. X can be 7, so that means the first bracket is 0. B times 7 subtract 5 equals 7 subtract 11. 2b equals negative 4 and b equals negative 2. Now choose x equals 5. A times 5 subtract 7 plus 0 equals 5 subtract 11. Negative 2a is equal to negative 6, so a is 3. Just write our answer. We had a over x subtract 5 plus b over x subtract 7. So we put in 3, because a was 3, over x subtract 5, and then negative 2 was b, over x subtract 7. So we can write it like this, or more sensibly, we put 3 over x subtract 5, and change this positive to a negative 2 over x subtract 7. And again, if you're not sure if this is correct, just multiply it until you get a whole fraction with x subtract 5, x subtract 7 on the denominator to check. So you check it by putting it back with this denominator.